In this video, we are going to understand what is Kubernetes and how it actually works. We are going to discuss why is Kubernetes so popular and what problem is Kubernetes actually solving. Then going deep down in the Kubernetes architecture, understanding master node, worker node, its component, along with a scenario where we are going to see what happens in the backend when you deploy your application on Kubernetes. So make sure you watch this video till the end and let me know if you have any questions, any doubt in the comment section. Let's start.
Alright, so I'm here on my computer screen and I have a Notion document created which contains all the notes about the topic we are going to be discussing in this particular video. We start with what is Kubernetes and why is it so popular, looking at how different companies are using Kubernetes. Then we look at different problems that Kubernetes is solving or what features or benefits you get when using Kubernetes. Then we go deep down in the Kubernetes architecture where we look at what is master node, what is worker node, what are components inside master node and worker nodes, also their roles and responsibilities. And to better understand this topic, I have a great example which explains what happens when you create a pod, how all these components work together inside a cluster. This will give you a good understanding of how Kubernetes actually works and what is it made of. So make sure you watch this video till the end. Let's start. So we will begin with why is Kubernetes so popular and why are companies actually using it a lot. If you follow recent IT trends, you might know companies are shifting from monolith architectures to microservices. Here are some big companies like Amazon, Coca-Cola, eBay, Etsy, Spotify, Netflix. All of them have shifted from monolith architectures to microservices. Monolith architecture is where you deploy an application as a single unit. So managing any of these services can be troublesome and can cause issue to the entire application. Also scaling and deployment is very problematic. So companies have shifted from monolith architectures to microservices. In microservices, you deploy application in independent services. So scaling and deployment is very easy. And each of this service is usually deployed as a container, most probably a Docker container. So managing these containers can be an issue. When you have a big application, you have multiple containers. You have hundreds or thousands of containers. So managing these will be a problem and you require a container orchestration tool, something like Kubernetes. So Kubernetes can help you manage all these multiple containers for an application. And Kubernetes does an excellent job as a container orchestration. So Kubernetes is amazing. It simplifies complex tasks, making it easier for DevOps engineers to manage applications seamlessly. So big companies like NASA, ChatGPT, Microsoft, Google, Spotify, Pinterest, almost everyone rely on Kubernetes. Here is a good blog that explains how big companies like Google, Spotify, Capital One, Pinterest, Adidas, all of them are using Kubernetes for their application. If you read here, Tinder, which is one of the largest dating application, shifted to Kubernetes in 2018. The Tinder platform operates completely on Kubernetes, which can handle all the individual microservices that Tinder uses. As of April 2019, Tinder was using Kubernetes with 200 services, 1,000 node, 15,000 pods and 48,000 containers. So this is why Kubernetes is so popular and virtually every job description for DevOps or cloud related roles include Kubernetes skills. So this is the right time for learning and mastering Kubernetes. Okay, now you know Kubernetes is used as a container orchestrated tool used to manage different Docker container, but that's not all. Kubernetes provides you with more features and benefits and actually solves many more problems that you might be facing when doing things manually. So in this section, we are going to understand what problems does Kubernetes actually solve. So we have an example here, which is a recruitment website. This recruitment website has been transitioned into microservices, deployed as a Docker container and managed using Kubernetes. So we are going to use this example to understand what problems are you going to face when you do it manually rather than using Kubernetes. So first is container orchestration. Obviously, when you have multiple Docker containers, if you're managing them yourself, it is going to be very complex and time consuming. So using Kubernetes, you can automate the deployment, scaling and management of microservices, ensuring seamless operation. So this is the first benefit of using Kubernetes. Next is declarative configuration. If you have already used Kubernetes or if you have done the previous projects that on this channel, you might know if we deploy anything on Kubernetes, we create a manifest file. A manifest file is something like this. Here is a manifest file to create a deployment, which is a Kubernetes object where we define everything. So we define how many replicas we want, what should be the deployment strategy, what should be the image used for this deployment, where should be the configuration stored and everything else. So using Kubernetes, you can declare what do you want And if you are not using Kubernetes, defining configurations for complex applications can be error prone. So if you do it manually, there are going to be errors, there are going to be problems. Whereas if you use Kubernetes, you can declare everything. So Kubernetes uses manifest or declarative configurations, enabling you to specify microservices desired state, and Kubernetes ensure that the actual state matches defined ones, minimizing configuration errors. So Kubernetes is using manifest files, and it will make sure that this manifest file is exactly what you want on the Kubernetes cluster, and it does that using controllers, which we are going to learn very soon. So make sure you watch the video and not just understand the theory, but also understand what is Kubernetes made of, how Kubernetes actually solve all these problems. So the second problem that Kubernetes solves is declarative configuration. When you declare things, there are less chances of getting errors. Next problem when not using Kubernetes is scalability. And this is actually a very big problem in microservices. Let's consider your website is now viral and there is a huge traffic coming in. You have huge traffic coming in for recruiters, for job vacancies, and now you want to scale up. You can dynamically scale up, or you can also mention replicas to be 4 or 5 or 10, anything you want. So scaling is a problem. Scaling microservices efficiently becomes difficult as the recruitment platform grows. Whereas when using Kubernetes, you can define the replicas in the manifest files, or you can also use something known as HPA or horizontal pod autoscaling, which uses metrics, and based on the metrics, it will scale up or down depending on the load or traffic or whatever metric you have, which can be CPU, memory, same as autoscaling groups in AWS. So Kubernetes automatically scales services based on demand, optimizing performance across cluster node. So this is also one of the problems that Kubernetes solves, which is scalability for microservices application. Now let's consider your application is more viral. There's a huge traffic coming in and you are making money. You have also solved the scalability issue using Kubernetes, but you also want the application to be up all the time, no matter what. Your application should never go down, which can cause issues or which can cause business loss. So how can you solve this problem? This is actually a very big problem in many websites and applications. So ensuring continuous availability for all services is challenging. Whereas when you use Kubernetes, you can define how many replicas you want. So in this deployment, we have defined to have 2 replicas of this particular deployment. So Kubernetes will make sure that at every time there should be 2 replicas all the time. Kubernetes ensures fault tolerance by automatically rescheduling failed containers and maintaining the desired state and ensuring high availability. So if any of these containers is down, let's say rather than having 2, we only have 1 container, Kubernetes will check that and automatically create a new container to maintain the count of 2 as defined in the manifest. And Kubernetes actually does that using replication controller, which maintains the desired number of pods replicas. So using replication controller, Kubernetes will make sure your application is highly available and you make money. So this is another problem that Kubernetes is solving, which is fault tolerance and high availability. Another big problem when using microservices application is service discovery and load balancing. When you have a microservices application, it's very hard to find other microservice or to communicate between them. For example, if you look at this diagram here, this is a microservices architecture for an e-commerce application where you have account service, order service, shipping service, and book service. So let's say user is here and he has ordered something. Next, the order service does not know where is the shipping service or what IP is it working on. Also, IP address for a pod is temporary and it changes every time. So it's a big problem to locate and communicate with other services. Discovering and connecting to dynamic services is challenging. Whereas if you use Kubernetes, it automates all of this using stuff like labels and selectors. So you can define labels and also selectors in your manifest files. You can use ingress controllers, you can use service endpoints and lot more that will help you automate service discovery and load balancing, facilitating seamless communication between service interfaces. Now let's talk about updating an application. Let's say you want to update your application, you have new versions for your microservices. But when you want to update it, you don't want the application to go down. Also, if there is any problem with the new version, you want to roll back, and when rolling back, your application should not go down, which is very complex when not using Kubernetes. So rolling update and rollbacks, updating or rolling back application without downtime is risky. But when you use Kubernetes, you have different deployment strategies which will help you do this very easily. In Kubernetes, there are 2 types of strategies: recreate and rolling update. Recreate will kill all the existing pods before a new version is created. So this will cause downtime. Whereas if you use rolling update, it will let you keep new version along with the previous version. And when the new version is ready, only then the previous version will be deleted. Which means at all times your application will have either new or previous version, and no downtime. Also, when rolling back, you will have no downtime, and these strategies can be defined in the manifest files here in the strategy section. So we have strategy defined as rolling update. So this is how you can solve another problem of rolling updates and rollbacks, where Kubernetes supports seamless updates without disrupting user behaviors and provides capability to roll back changes as well. So these are all the benefits and problems that Kubernetes is actually solving. I hope now you have an idea of how powerful Kubernetes is and how Kubernetes can help you with your microservices application. So now let's check out what is inside a Kubernetes cluster, understanding Kubernetes architecture in depth. We are going to see what is the cluster actually made of, what are components inside master node and worker node, what are their roles and responsibility. Then moving on to understand how is an application deployed on Kubernetes, what happens in the backend, what is going on with other components, and how they actually work. So let's get started with understanding what is Kubernetes architecture. So at a very high level, Kubernetes cluster consists of two main things: master node and worker nodes. Master node, also known as control plane, is responsible to take cluster decisions and also responsible to handle things inside the cluster, whereas worker nodes are where actual workload happen, where the actual application pod is running. So everything happening in the cluster is going to be managed by master node or control plane, whereas responsibility of worker node is to receive instructions from the control plane or this master node and manage local executions of workload. So in this worker node, your application will be running inside a pod. A pod is the smallest unit in Kubernetes cluster. If you look here, this is a pod inside a worker node. A pod is going to contain your application containers. Usually a pod will have single container, but there can be more than one containers as well. So this is a pod having one container. This is another pod having two containers. And the key components of master node include API server, controller manager, scheduler, etcd, whereas components of worker nodes include kubelet, kubeproxy, and container runtime. You have a diagram here which has all the master node components and worker node components as well. We are now going to look into what is etcd, what is the purpose of this component, what is controller manager, what is kube API server, what is scheduler, what is kubelet in worker node, what is kubeproxy in worker node, and lot more in depth. So let's go ahead and understand each of these components one by one and how they actually work inside the cluster. So the first master node component that we are going to look into is etcd. So what is etcd? etcd is a distributed key value store that serves as a primary data store for Kubernetes. It's a key value store that is used to contain all the information about the cluster. etcd will have all the information of what node is running, what is the pod running on the node, or what are different services inside the cluster and everything. So it stores the configuration data that represents the state of entire cluster and including information about nodes, pods, services, and more. Now we know etcd is used to store and retrieve configuration data for all the cluster components, which makes etcd a very important component of master node, and also the data inside etcd is very important. So we need to make sure that it's not deleted or not lost. One of the responsibilities of etcd is to consistently replicate data across cluster of etcd node, providing fault tolerance and high availability to make sure that the data is not lost at any point. Now I also have a documentation attached for all of these master nodes. You can go and read about it if you want to. Here is the documentation of etcd by Kubernetes. So if you read here, etcd is a consistent and highly available key value store used as Kubernetes backing store for cluster data. One of the important questions for CKA is backing up data, which you can see here in this section, and you can back up data using these commands. etcd uses CLI tool, which is etcd-ctl, and it has two APIs, version 2 and version 3 right now supported. If you want to back it up, you can run the command along with certificate files which are mentioned here. So this is the command to take the backup, and you can also restore it. So this is how etcd works. We are going to see more in depth about etcd when we look at the example below. So this is etcd, which is used to store all the cluster information about pods, nodes, services, everything, and storing the cluster state. Next, very important master node component is kube API server. If you look at this Kubernetes architecture, you will see API server is a center of communication for all the components inside the Kubernetes cluster. In fact, etcd cluster only talks to API server. So if scheduler or any other components want to get some data from the etcd, they will ask the API will get the data, and then it will be served. Not just this, Whenever you run a kubectl get pod or get nodes command to retrieve the information, it actually goes to API server. API server validates and authenticates the request, then retrieve the data and give it out to the user. API server is central management entity for entire Kubernetes cluster. It exposes the Kubernetes API, which allow users, administrators and other components to interact with the cluster. All the other components communicate with the API server to read or modify the cluster state. So now we understand Kube API server exposes an API which lets you communicate to the components inside the cluster and also to get the data. So here are some of the responsibilities. It validates and configures data for API objects, and you can talk to the API server using kubectl commands, which is command line tool, also K9S. You can also talk to the Kube API server using Kubernetes UI dashboard or using API REST methods like get, put, post, delete to retrieve the information. It also acts as a front end for etcd data store. As I told you, etcd can only be communicated through the API server. And I have a documentation attached for Kube API server which you can go and access. According to the documentation, the API server validates and configures data for API objects, which includes pods, services, replication controllers and others. So this is the documentation. If you want to read more about API server, go ahead and read on the official documentation. Next, moving on, we have another very important masternode component, which is Kube Scheduler. Kube Scheduler, as the name suggests, is responsible for scheduling pods on the worker nodes. So let's consider a scenario where a user has requested to create a pod using the command kubectl apply -f the pod manifest. The API server is going to get that request, and scheduler is going to check which node is the best fit for the pod, and it is going to decide the node on which the pod has to be placed. Remember, it only decides where to place the pod but not actually places it. So it's going to decide which node is the best on different factors like the CPU requirements, memory requirements, labels, selectors, node affinity rules. There are many things that scheduler looks at before deciding the right node. So Kube Scheduler is responsible for placing pods onto the nodes based on the resource requirements, constraint and other policies. It makes decisions on where to deploy the pods in the cluster. So it only makes decision on where to deploy it, but don't actually do it. It only finds the right node for the pod. So responsibilities include watches for newly created pods which don't have any assigned node, selects an appropriate node for each pod based on resource requirements, node capacity and other constraints. Once the Kube Scheduler has found the right node, it will update the pod information in the API server, assigning it to specific node. So here is the documentation for Kube Scheduler, and you can go ahead and also look into it if you want to learn more about Kube Scheduler. If you look here, the documentation says Kubernetes Scheduler is a control plane process which assigns pods to the nodes. So it only decides where should be the pod placed, but don't actually do it, which we know. So who actually creates the pod on the worker nodes? It is actually done by a component in the worker node, which is kubelet, and we are going to look into that very soon. But before we go ahead and understand the worker node components, there is still more to the master node, which is Kube Controller Manager. So what is Controller Manager? Controller Manager is a component in master node that continuously monitors and troubleshoot. But what does it monitors and troubleshoot? Controller Manager are of different types like node controller, replication controller, endpoint controller, service account controllers, token controllers, and lot more. So depending on the type of controller, it will actually monitor that component and troubleshoot if there are any issues. So looking back here, Controller Manager run controller processes that monitors the state of the cluster and respond to changes to drive cluster towards the desired state. So these are actual components that will continuously monitor and make sure that the cluster is as desired in the manifest files. So there are different types of controllers like node controller, which monitors and responds to the changes in the state of nodes, replication controllers, which maintains the desired state of pod replicas, endpoint controllers, which populates the endpoint objects, and there are a lot more which you can see here in this particular screenshot. So here are the list of controllers that you can enable, and you have all controllers which are attached, detached, bootstrap signer, cluster role aggregation, cron job, CSR approving, and lot more. You also have something known as Cloud Controller Manager that is used whenever you are deploying your Kubernetes cluster on the cloud to use different features. So in cloud-based Kubernetes installation, the Cloud Controller Manager integrates with cloud-specific APIs to manage external resources such as load balancers and storage volumes. So it interacts with cloud providers API to manage resources, abstract cloud-specific functionality for the core Kubernetes components. So now we have understood all the masternode components. We know etcd is used to store the data about the cluster, which will have data or information about nodes, pods, services, everything. Kube API server is used to communicate and to retrieve information from the different components and also to talk to the cluster. Kube scheduler is used to assign the pod to a particular node, which is the best fit for that particular pod. Next, we know controller manager that will continuously monitor and troubleshoot if there are any issues with the cluster, and there are different types of controller manager. So these are all the components that we have seen: API server, HCD, scheduler, controller manager, and cloud controller, which is AWS in this case. Now let's go and understand what are the components inside the worker node. So what is kubelet, what is kubeproxy, what is container runtime, and lot more. The first worker node component that we're going to look into is kubelet. So kubelet is an agent that is running on every worker node, which is responsible to create pods on the nodes, also to monitor them, send the status back to the API server, and ensure everything is working fine. So as we know, scheduler is used to assign the pod on a particular node, but kubelet is responsible to create that pod on that node. So whenever a request is received from the API server, kubelet is going to tell the container runtime to run the image and start the container for that application. The kubelet is an agent running on each node, responsible for creating and maintaining the state of the pod and ensuring they run as expected. Responsibilities include listening for pod related instructions from the control plane, which is a Kube API server. So whenever we have a request from the API server to create a new pod, kubelet is going to do that on the node decided by scheduler, and kubelet is going to tell that container runtime, which is going to be Docker in most cases, but can be any other runtime as well. Then ensures containers within the pod are running and healthy, and reports node status and usage back to the control plane. So this is the task of kubelet, which is to create the pod, ensure it is running all the time, and give the status back to the control plane. I also have a kubelet documentation attached here. If you want to learn more about kubelet, you can go ahead and read about it from the official documentation. Now whenever a pod is created, there are a few more things that is required, which is the container runtime, also known as CRI. Along with this, you also need to have networking for the pod and storage configurations if required. So there are three things that you require: CRI, container runtime interface; CNI, which is container network interface; and CSI, which is container storage interface. CRI, or container runtime interface, is interface for communication between kubelet and container runtimes, defining how containers are managed within the pod. Then you need CNI. CNI is container network interface, which specify how network plugins interact with container runtimes to provide networking for the pods in the Kubernetes cluster. Then you have container storage interface, which enables Kubernetes to work with various storage systems and drivers for persistent storage volumes attached to the pod. If you remember, we had a Kubernetes voting application project on this channel, and whenever we want to create persistent volumes for our pods, we need to enable the EBS CSI plugin in our Kubernetes cluster. If you don't remember that, make sure you watch or you complete that Kubernetes voting project as well. The last worker node component in the Kubernetes cluster is kubeproxy, which is actually a component that is used for communication between services and pod. So kubeproxy is responsible for network proxying and load balancing, ensuring communication between services and forwarding external traffic to the correct pods. Responsibilities include managing network rules to enable pod-to-pod communication within the cluster, implement service load balancing, distributing external traffic to service endpoints, facilitates network policies for secure communication between the pods. So kubeproxy is actually used to communication, and it does that using IP tables, and you have a documentation for kubeproxy here, which you can read in depth if you want to learn more about kubeproxy. Now let's understand what happens in the backend when you run kubectl create or apply commands to create a pod or run your own application. So I'm considering you have an application that has been Dockerized and the image is uploaded on Docker Hub. You can use that image to create a pod, something like this. So this is a manifest file for creating pod, and the image used is nginx. You can use any image you want to. In this example, we are going to see how Kubernetes components work together to actually create a pod, what happens when you run the kubectl apply command, what data is stored in the HCD, and how is the pod scheduled on the worker node. So let's go and do this hands-on. I already have minikube set up. So if I run the command minikube status, you will see a cluster is running. So control plane, host, kubelet, API server, all of them are running. And if I show you kubectl get pods inside the kube system namespace, you will see all the pods running. So etcd is running, kube API is running, controller is running, proxy is running, scheduler is running, and all of them is running. So we are going to do the steps to understand what happens when you run the kubectl apply command, what data is stored in the etcd, and everything else. So I have this pod manifest which I'm going to copy and create a file. So I'm going to say nano my dashpod.yaml. Nano is a text editor and we are getting a manifest file which is YAML. If you haven't checked the previous video which explains all the prerequisites you need to know before learning Kubernetes, YAML is one of the prerequisites that you need to know. So I'm going to save this manifest file and now I'm going to run the command kubectl apply -f, name of this file. When I run this command, kubectl will submit the pod configuration to the Kubernetes API server. This Kubernetes API server will validate the pod configuration and store the data inside etcd. And we can check that data using this command. So let me run the command kubectl apply command with the file name which is mypod.yaml. Once I run this, you will see the status is mypod created. Let's see. I'm going to say kubectl get pods and you can see the container is now in created state. -w, and now it has been running state. So in this time frame, the scheduler decides the node to place the pod and kubelet then places the pod on the worker node as well. For now, this minikube only has one node, so the pod will always be placed on that node. So if I run the command kubectl -o wide command, you will see all the pods are placed on minikube node because there's only single node. But when you have multiple nodes, kube scheduler will find the right node and place the pod on that. Now let's see what data is stored inside the etcd, which you can get by this particular command. So I'm going to copy this command and we will see the pod status inside the etcd. So once I paste this, you can see this is the status or this is the information present inside the etcd. The image used is this, image id is this, the container is ready, and all the other information. Now moving on, so we already know scheduler is the one which decides which node is the best, and you can check the scheduler decision by running this particular command. So if I run the command, it will tell me what node is the pod placed on. So minikube is the name of the node on which my pod is placed. But kubelet actually runs the pod or starts the pod, and you can check that by going inside that node and running the command. So if I go inside the minikube node by running minikube ssh, so I'm inside the minikube node, and if I run the command docker ps, here docker is the container runtime, so I'm going to run the command docker ps, which will give me the list of containers running. So we will find nginx here, which is what we ran right now 2 minutes ago. If you want to get the IP address that is assigned using kube proxy, I will first exit from this, clear the screen, and run this command, which is to get the IP address of my pod. First run this command kubectl describe my pod and get the IP address. So this is my IP address, which is 10.244.0.120. This is the IP address assigned to the pod. So now the pod has been created. It also has an IP address. The data is stored in the etcd as well. So this is actually what happens when you run the kubectl apply command or even push a new update for your application. I hope now you have an idea of what Kubernetes is, what problem is it solving, what is the Kubernetes architecture all about, what are different components in it, and I hope this video was informative. If you have any questions, any doubt, do let me know in the comment section. Also, if you want me to share this document, you can let me know in the comment section. I can upload this on LinkedIn or GitHub if you want me to share it. Thank you and have a good day.